All right, here's this bell work, and it's just solving an equation. We got x's on both sides though, so we do need to determine which side we want the x's on. There's no distribution, no combining like terms right now though, so I'll just keep the x's on the left and the numbers on the right. So this negative 5x, that's good. It's an x term, but this negative 8, no, it doesn't have an x. Okay, so we will zero that out by adding 8 to both sides. And then we'll zero that out. So I'll drop my negative 5x here, which now equals negative 4 plus 8, which is positive 4. And I'll drop this negative 6x, so minus 6x right there. And now, further scanning this, I see the 4 is on the number side of things, that's good, but the negative 6x is on the number side of things as well. So we don't want any x terms here on the right, which means I will also zero that out by adding 6x to both sides. So negative 5x's plus 6x's, that would give me 1x's. And this would equal the 4. I'll just drop it. And yeah, the negative 6x zeroed out just like we wanted. And the coefficient of x right now is a 1, so I'm just going to get rid of that right there, okay? Now, I will check the answer here, though. So I'll say let's go ahead and replace the x here with 4. And this one with 4, and we'll see if this is a true statement. So on the left side, negative 5 times 4 is negative 20 minus 8. That would give us negative 28. There's our question mark. And then over on the right, it would say 6 times 4, which is 24, but that's negative 4 minus 24, which is also negative 28. So it ends up being a true statement, which is what we wanted to see, because now we know that x equals 4 is the actual solution to that equation. So this one, again, no distribution, no combining like terms, only principles of equality to solve this one, and we were good. I know when an equation has no solutions, one solution, or infinite solutions. There's our objective. Take a minute and copy that down, and I believe we do have a mastery quiz on this kind of stuff next time. All right, so it is possible for equations to have, of course, we see in one solution. That's pretty normal for us, just like we saw on the bell work. There was only one solution to that equation, which means that there was an infinite number of solutions that would make it false, but there was one value that made it a true statement. But we're going to find, in some cases, there will be no values of x that you could replace, no values that you could replace x with to make it true. Or we'll also find that it is possible to replace any value of x to make it true, okay? So again, that's what we mean by no solution. No solution or solutions. That means no value. Let's see. No value can replace x to make the statement true. Okay. And then again, infinite solutions. That would mean that you can replace x with any value and the equation will be true. Okay, now when we say any, we mean any negative, any positive, any decimal value, any fraction, positive or negative, doesn't matter. You'd be able to replace x with anything and you'd find that it would be a true statement. And we'll look at some examples to see how that works. So again, what is a solution? Just like we saw in that last slide, a solution to an equation is what value you can replace x with, or whatever the variable is, to make the equation a true statement. Okay, it's got to be a true statement. Just like we've seen in the past, right? We could say, well, 10 does equal 10, and of course we'd say, hey, that's true. But if you started comparing 10, let's say even with like 105, right? Well, now we would say that right there is false. Okay. So we have to be able to replace, especially if there's an x somewhere in there, you have to be able to replace x to make it a true statement like we see here on this top example. So principles of equality, once again, we use our principles of equality. Addition and subtraction, that is to make 0, just like we saw in the bell work. We use these to make zeros. And And that's just to isolate the x's. Once you get the x's isolated, then it's just a matter of either multiplying or dividing by the coefficient. So that's where we make ones with multiplication or division. And but again, it's specifically meant to make the coefficient a 1. All right, so here's our first example. And we do see a need for distribution on this stuff. And hopefully you guys understand as well that the mastery quiz that we took last time pretty much had this stuff on it. So distribution, combining like terms, principles of equality. There you go. So on this one, I'm going to take this -4 and distribute it into this parentheses. If it helps you to see that phantom 1 there with the n, then do it. Show it. Okay? In fact, if it helps you to show with this n as well, phantom 1 right there, do it. Okay? So that's a -4 times 1n distributed. Remember, distribution is multiplication, so that'd be -4n's there. And then -4 times 5, that'd be -20. Of course, we write that as -20. Now, nothing else changed for us in this equation. Everything else remained the same. Okay? But that takes care of all the distribution we see in this equation. Now we'll look to combine any like terms, which I see some n's here on the left, the -4n's and the -1n. That would give us -5n's. And we got the -20 there. And then everything on the right side of the equal sign. Okay? So we just barely had 5 terms. Now we're down into 4 terms. And now it looks like a problem that's very similar to the problem we saw in the bell work. So we're looking for principles of equality at this point. And we have n's on both sides of the equal sign. So I'm going to have to choose which side I want the n's on. I'll put them on the left, because that's what we've been doing. So scanning this equation, the -5n is on the n side of things. That's good. But the -20, no n. Which means I want to zero that out by adding 20. So I add 20 to the right side, and that will zero that out right there. I'll drop my -5n though. And this would equal, some of you may notice that the -20 plus 20 there, it zeroes out as well. But I do want to show the 0 here. And the reason why that is because it's on the number side of things. If I don't show the 0, what would happen is I'll drop the 8n. And this would be okay to drop your 8n right here. But the 8n is on the wrong side of the equal sign. We don't want it on the number side of things. Okay, so I do want to see that 0 from the -20 plus 20 right there. And then it was a positive 8n. But like I was just saying, the positive 8n here, it's on the number side of things, so I don't want that on this side. I got to zero that out as well. So I will do that by subtracting 8n from both sides. That will give me -13n's, which equals, and again, we see the need to see that 0 there in green. Of course, you could have said, well, these would zero out, and you could drop that as 0. Yeah, that's true. Some people would probably keep that as 0n, which is what we don't want, though. So you got to be careful with that. Now, some of you know the answer here. Like if you think about this, -13 times what is 0? I think some of you guys could do that in your head. I'm still going to do this with the principles of equality, so I'm going to divide both sides by the coefficient. -13 makes that a phantom 1. N equals, put that in the calculator, 0 divided by -13. It'll tell you that n would be 0. Now, does this mean there are 0 solutions? No, it means the solution is actually 0. There's a difference. And it's important that you know the difference here. Can we check this? Sure we can. Replace the n's with zeros. And then check for truthfulness, right? So on the left side, we'd get -4 times 5, which is -20. So that on the left side, there's our question mark, we get -20. On the right side, again, we get -20. So that would be true. And then I know that I can box in this answer with confidence. So this one has one solution to it. One solution, that's it. So this one, we use principles of equality, we use distribution and combining like terms, and we found there was one solution. And now we know what the solution is. If there's one solution, we should know what it is. If there's an infinite number of solutions, of course, we wouldn't have to state all of them. And if there's no solutions, we would just need to say that as well. But you'll use the same process to get to that point. And so again, how can we tell if it has one solution, no solutions, or infinite solutions? Well, let's see if we can find a pattern here. So on this one, Yep, we're gonna need to use some distribution here first by distributing this 5 into this parentheses. Okay, so that's multiplication. Distribution is always multiplication. So 5 times 1 is 5. And then 5 times negative 2x's would be negative 10x's. And then, yeah, we didn't really do anything with the rest of that equation there. So this is what we have now. And after the distribution, we're looking to combine like terms. And I got these negative 10x's and 7x's, which would result in how many x's? Negative 3. And I'll drop the 5 there, so that reads 5 minus 3x. And again, we didn't do anything with the right side of the equal sign, so there we go. Now, if you'll stop and look at this, you'll notice something that happened on this equation. The left side here, what I have in red and purple, matches what was already there on the right side. That means something. Well, we can continue our principles of equality to see exactly what that means. So let's continue here. So I'm going to put my x's on the left again, and I'll put the numbers on the right, which means my red 5 here, it's not an x term, it's got a 0 out. So I'm going to have to subtract 5 from both sides, okay? So that will 0 that out. I'll drop my negative 3x, which equals now 5 minus 5. Again, I would want to show that 0 because the other term is negative 3x there, which I draw. Okay? Yeah, and again, I'm showing the 0 because it's on the number side of things. I want to see that number. So now the negative 3x in black there, I want to 0 that out, so I'm going to add 3x's to both sides. And that's a principle of equality there. So just with the x's, on the left, I got a purple negative 3x and then an orange positive 3x. Negative 3x's plus 3x's would be 0x's. Now that's important as well. Just to notice this part, 0x is just as important as noticing what we saw up here where the two sides of the equations match. Now I'm going to drop the 0 from in green there, and then we zeroed out the negative 3x's there in black. So the question here is, you could say you're going to divide both sides by 0, but anything goes into 0 an infinite number of times. So we should be able to stop right here and say what the solution is. And the solution, and again, this is related to what we saw on this line right here. So let's go and highlight these two lines. This one right here, or this one right here. You need to notice either one of these at any time while you're solving, okay? And the question is, and it kind of solves up here, but if you get down to this point, you could say 0 times what is 0? And you should be able to think about that, not too extensively, you shouldn't need to, but like, what can I multiply by 0 to get 0? I can multiply 1. I can multiply 2 million by 0 and still get 0. See what I'm saying? So anything multiplied by 0 is going to give us 0, which means that on this problem, we're actually looking at an infinite solutions problem. And again, it's infinite because you can replace x with an infinite number of values and you still get 0. Okay? Look, you could even replace x with 0. 0 times 0 is going to equal 0. So if you ever see something like this, 0x equals 0, boom, you get infinite solutions. But if you notice it earlier on, that you have matching expressions on both sides of the equal sign, that also would have told us that you have infinite number of solutions. Okay, so again, what that means is you can replace x with anything, and you will get a true statement, not only here, but in the original equation as well. Because remember, these are all the same. We've just manipulated them with some principles of equality. See, on the homework, you'll type in ARN, which stands for all real numbers. It means the same thing as infinite solutions, meaning that any real number that you put in for x would make it a true statement. Well, what does that mean for not real numbers? Because if we say there's real numbers, there has to be not real numbers. Yeah, that's true, but we're not dealing with that in 8th grade, okay? So there we go. That's the first time we've seen this where there's an infinite number of solutions. But again, the one here at the end, hopefully that makes sense if this one does not. Okay, anything times 0 will give you 0. All right, here's another example for us. And again, we've got some distribution, no problem. I don't see that we'll have to use any combining like terms. That's okay too. But I'm distributing this negative 2 into the parentheses, okay? So to start out, remember that this shows us negative 2 times negative 4, and also negative 2 groups of 4x's right there, okay? Remember, distribution is always multiplication. And negative 2 times negative 4 is positive 8. And then we had negative 2 times 4x's, which would be negative 8x's. And this would equal the right side, which is 8 minus 8x. Now again, some of you'd say, I already noticed what's going on here, Mr. Sal, and that's fine if you do. I'm going to pretend like you don't, not to drag this on further than it needs to, because I'm just doing it because not everyone would notice, okay? 8 minus 8x is going to equal 8 minus 8x. This will always be true, okay? And again, some of you noticed that just by the distribution, but if you didn't notice it, then you'd have to continue with principles of equality until you did notice it, okay? So again, x is on the left, numbers on the right, meaning that that 8 in red, it's got a 0 out. So I'm going to subtract 8 from both sides. And that will zero that out. So I'll drop my negative 8x in red, which now equals 8 minus 8. Again, I want to show that 0 because it's the number side of things, and then I'll drop my negative 8x there. Now I don't want that negative 8x in black there because it's on the number side of things, so add 8x to both sides. Okay. And what happens here? Well, negative 8x on the left, the red negative 8x and the plus 8x in green there would give us 0x's, which should equal here. I'll drop this purple 0 right there. And then in black and green there, we got negative 8x plus 8x, which is, it's zeroed out just like we wanted. Okay, now, again, if you did not notice that it would be infinite solutions here, you need to notice at this point because anything times 0 is 0. Okay, so again, this would come out as infinite solutions. But again, I'm pointing this out. If you notice that these were the same up here, you wouldn't have to do all this work right here, and you may have stopped. But if you didn't, you may have to do some extra work to see that. Okay. And again, this should make sense. If you replace x here and x here at the same number, they're already matching, which means that it wouldn't matter what you replace x with. You can replace with anything: fractions, decimals, negatives, positives. It will always be true because it's the same on both sides. All right, here's a new one for us. And this one has some distribution. But why don't you guys take a minute, try this one out, then we'll go over, okay? 1 minute. If you're still working on this, go ahead and finish up and then kind of catch up to where we are. If you solve this all the way through, I believe you should have gotten 0n equals negative 4, okay? Now we'll talk about what that means, but let's look at how we solve this. So first off, distribution, so that's negative 2 times 1, which would be negative 2. And then that's negative 2 groups of negative 4n's. Remember, the negative from the minus sign would make that now positive 8n's. Okay, so what do we have now? 2 plus 8n equals negative 2 plus 8n. Now, some people would look at this one and say, hey, look, they're matching. They're not matching. Okay, you got the 8n's that do match, but you got a 2 and a negative 2 that don't match. That means something, okay? And right now, once we get enough experience with this, you could stop right here and tell us what the solution is. And I think some of you know where this is going. But I'll use some principles of equality now because there's no combining like terms. I'm going to put my n's on the left and numbers on the right. We'll stick with this strategy, which means the positive 2 in black there has to zero out. I'm going to have to subtract 2 from both sides. All right? So that will zero that out. I'll drop this 8n in black, which now equals negative 2 minus 2 will give us negative 4. And then the positive 8n is going to drop. All right? Now, with the answer to this equation right here, if you didn't notice right here that what the answer is, hopefully you would notice right here. But if not, we can continue by saying, let's go ahead and get rid of this 8n right here. Okay, so I'm going to zero that out because that 8n in red there is on the wrong side, right? It's on the number side of things. It does not have an, it does have an n. So 8n minus 8n there in red and in green, yeah, that zeroes out, okay? And then notice here in black and green, I got 8n's minus 8n's right there. How many n's would that be? It'd be 0 n's. Okay, and then the negative 4, yeah, we just dropped that to get negative 4 here like this, okay? Now, what does this mean? Well, it means, if you look at the equation right here, again, we want to replace n with some value to make this a true statement. Remember, the equals sign is a comparison, and we got to make it true. We have to force it to be true. So what value of n can you replace here to make this true? Some students would say, look, replace it with -4, and then it would be true, okay? And then you could start replacing values. Again, -4 times 0, that's not -4, that's 0, okay? Could I replace it with a large number, like a billion? No, it'd still be 0, right? What if I replaced it with a negative value, like -400? Yeah, it'd still be 0, okay? So what this means is you can replace n with any value you find, and you'll never find one that would make this true. So this one has exactly no solutions. Which, again, on Canvas, if you see an equation that has no solutions, you'll just write NS, and then it knows you means no solutions, all right? All right, so what this means is back here, if you see that there's an equal number of n's on both sides, they will eventually zero out. And if you have a number other than 0 right here, like we saw in the last two examples, you'll automatically find that there's no solutions, okay? You could have done that from here as well. The n's match, but the numbers do not, which means automatically you will have no solutions. But this would be after combining like terms if it were necessary. Now, a common mistake we see on tests and quizzes for this is where students will say 8n minus 8n. Instead of putting a 0 there, they just put an n, okay? If you did this, you would have indicated that there would have been 1n, right? That's a phantom 1 right there. And so you need to remember that it is possible here to have 0 n's like we see not only in this example, but the last two as well, okay? So please do not make that mistake because it will throw you off. N is not -4. And again, if you found that, you could go back to the original equation. If you just put that in, you'd find that it would give you a false statement. You'd have to go back and reevaluate what you did here. All right, having seen that example, try this one out. Again, take a minute, try this one out, then we'll go over, okay? 1 minute, go. All right, so for this one, we'll go in and we will do some distribution here to start out with. So that's 8. Again, it's multiplication. Distribution is always multiplication. That's 8 times 1t. 8 groups of 1t's would be 8t's. And then 8 groups of 5 would be positive 40, okay? And then this equals everything on the right side. So, and again, I think some of you would know at this point what the answer is to this problem, because there's a matching number of t's, but there's not a matching number of, well, numbers, okay? Now, if you didn't notice that, once again, we can just continue as though we didn't notice. I'm going to put the t's on the left and the numbers on the right. And so the 8t in red there is okay, but the positive 40 in red, no good. It does not have a t with it, so I'm going to have to subtract 40 from both sides. And then we'll zero that out. I'll drop my positive 8t in red, which equals this black 8t. I'm going to drop it. And then 39 minus 40 would be -1. But now, this black 8t, yeah, it's on the number side of things, so I got to zero that out as well. Subtract 8t's. And again, please do not put this as 1t. It's 8t's minus 8t's. It's okay to have 0 t's. It's going to tell us something about the equation. Our black 8t zeroed out the green minus 8t. And then I'm going to drop this -1, okay? So again, what can I multiply by 0 to get -1? You can never multiply anything by 0 to get -1. So this one has exactly no solutions. Now, if by chance you had put the t's on the right and the numbers on the left, you'd get something like 1 equals 0t. Again, this is still false, always. It's always going to be false because you can never replace anything with t, multiply it by 0, and then get 1. You can never do that. No solution still. All right. Now, again, on this one, could we tell for sure how many solutions there are before even solving this one? Hopefully we can. And if not, it's okay. You just use regular problem-solving strategies or equation-solving strategies to solve this, okay? But remember, for there to be no solutions or infinite solutions, there has to be the same number of x's on both sides, automatic. This one, there's only x's on the right and numbers on the left, which means that this one should have one solution, which means we also need to find it, because on the homework, it will require that, okay? So I'm going to take these -4x's and these -7x's and combine them, okay? So that'd be a total of -11x's. So I end up with -11 equals -11x's like this. And so we don't really need to choose which side we want the x's on because they're only on the right side here. So I'm going to keep them there, and I'm going to divide both sides by the coefficient. The red negative 11 specifically makes that a phantom 1x. See, in this case, we get the 1x. Okay, that's what we want. And negative 11 divided by negative 11 is 1. Okay. Could we check this for truthfulness? Yeah, of course we could. Okay, so that means that I would go to the original equation, replace the x's with 1. And negative 4 times 1 minus 7 times 1, yeah, put that in the calculator, you will get negative 11. So negative 11 does equal negative 11. That is true. Which means that this x equals 1 is the solution. Okay, this one does not have infinite solutions. It doesn't have no solutions. It has one solution, and we know what that solution is. Well, there's our objective. I know when an equation has no solutions, one solution, or infinite solutions. And do remember that with no solutions, okay, no solutions would indicate that you have the same number of x's on both sides of the equation, or you have 0x, but the numbers don't match, or in the end you'd have like 0x equals not 0. Then you'd have no solutions. For infinite solutions, in the end, you would have 0x equals 0. That will always be true, no matter what value you replace x with. So that is how we can tell if there's infinite solutions. So what about one solution? It just means that there's not a matching number of x's on both sides. Automatic, if you see that, then you would know that there's one solution. You would actually need to solve that on the homework.